December 18, 1945. In the shrouded world of secret wartime technology, some secrets are whispered, myths spoken in hushed tones in briefing rooms and darkened hangars. They are tales of miracle weapons, of devices that can turn the tide of a conflict with the flick of a switch or the turning of a dial. But one secret, one device, was held so sacred that the men who operated it had to swear a blood oath to protect it with their lives. They were told that if their aircraft was going down, their first duty wasn't to save themselves, but to destroy the device with a thermite grenade, melting its intricate guts into a useless slag of metal. If capture was imminent, they were to use their service pistol on it, and only then on themselves. This device, a squat black box weighing 50 pounds, was considered more valuable than the four-engine heavy bomber that carried it into the hostile skies over the Third Reich. It was known simply as the Norden. To the American public, it was the miracle that would allow their boys to drop a bomb into a pickle barrel from 20,000 feet. To the bombardiers who peered through its telescope, it was a temperamental, genius-level calculator, a mechanical brain of gears and gyroscopes that promised to make the chaos of aerial warfare precise, and therefore winnable. But to the men on the other side, the seasoned pilots of the German Luftwaffe, it was something else entirely. It was an object of frustrating obsession, a piece of enemy engineering so advanced, so impossibly accurate, that they would come to envy it, to covet it, and in their own professional way, to beg their own high command for anything that could match its mythical capability. This is the story of not just a piece of hardware, but of a legend, forged in secrecy and fire, and why the best pilots in Germany looked to the skies and wished the American secret was their own. The year is 1941. The skies over Europe are a maelstrom of conflict. The Battle of Britain has reached its brutal crescendo, and the Luftwaffe, while bloodied, remains a formidable force. On a makeshift airfield in occupied France, Hauptmann Klaus Richter pulls off his leather flying gloves, his face etched with a familiar mixture of fatigue and frustration. He is an ace, a veteran of the Spanish Civil War and the blitzkriegs through Poland and France. He knows his aircraft, the Heinkel HE-111, like the back of his hand. It is a robust and reliable bomber, the workhorse of the German air arm. Yet as he debriefs his crew, the same old problem hangs in the air, thick and acrid like the cordite from their defensive machine guns. Accuracy. They had just returned from a raid on an industrial complex near London. They had faced the fury of Spitfires and the black puffballs of anti-aircraft fire, what the British called flak. They had dropped their full load of bombs, and from their vantage point, the explosions looked impressive, a chain of smoke and fire blossoming across the target area. But the reconnaissance photos that would arrive tomorrow would tell a different story, a story of near misses, of bombs cratering empty fields, of damage to civilian areas but with the core of the factory, the true objective, remaining stubbornly intact. Klaus slammed a fist onto the briefing table. "It is like throwing spears in the dark," he spat, his voice low and guttural. His bombardier, a young man named Franz, merely shrugged. "Hauptmann, the Luftwaffe 7 is the best we have. I do my best. The wind, the vibrations. At 5,000 meters, a small error becomes a kilometer." Klaus knew the boy was right.
The German bomb sight, the Luftwaffe 7, was a marvel of Zeiss optics. It was a telescopic sight that required the bombardier to manually input data, to make constant, skilled adjustments, lining up his crosshairs and timing the release with instinct and experience. It was a good system, a solid system, but it was a human system. And at high altitude, with the plane bucking from turbulence and enemy fire, the human element was prone to error. The theory of strategic bombing, championed by minds like Douay and Trenchard, was supposed to be the new face of warfare. It promised to cripple an enemy's industrial heart, to break their will to fight by destroying their means to do so. The bomber, they said, will always get through. But getting through was only half the battle. Hitting the target, the right target, was proving to be an almost insurmountable challenge. For every successful raid, there were dozens of failures, missions where brave men died for no other reason than to rearrange the French countryside, or create new craters in the English suburbs. Klaus Richter and thousands of pilots like him were beginning to understand the brutal equation of their trade. Inaccuracy meant more missions meant more exposure to enemy defenses, and more exposure meant more losses. Their technology, their very doctrine, was being tested and found wanting. They were skilled, they were brave, but they were fighting a war of precision with tools of approximation. Deep down, a cold dread began to settle in Klaus's gut. The British were resilient, and across the Atlantic, the industrial might of the United States was stirring. If the Americans entered the war, they would come with thousands of bombers. And if they couldn't hit their targets any better than the Luftwaffe could, the war would become a meat grinder of attrition, a contest of which side could absorb the most punishment. He looked out at the darkening sky, wondering what secrets the enemy was working on. He could not have known that in quiet, guarded facilities across America, the answer to his frustrations was already being assembled. A device that promised to take the guesswork out of bombing and turn it into a science. Thousands of miles away, in the arid heat of a New Mexico desert, Lieutenant Jack Riley wiped sweat from his...
Their instructor, a stern captain named Harris, walked among them. "Gentlemen," he began, his voice barely above a whisper, despite the soundproofed walls. "You are looking at the most important piece of military hardware in the United States arsenal. The atomic bomb project is still a theory. This is a reality." He patted the black metal housing of the Norden. "Before you were allowed in this room, you signed an oath. You swore to protect this instrument with your life. You swore to destroy it rather than let it be captured. I will remind you that the penalty for failing to do so is treason. The penalty for treason is death. Are we clear?" A chorus of "Yes, sir," echoed in the small room. Jack felt a thrill of importance, mixed with a heavy sense of responsibility. This was the weapon that would win the war. This was the pickle barrel sight. The legend had already spread through the Army Air Corps. The Norden, they said, was so accurate it could drop a 500-pound bomb into a barrel from 4 miles high. The story was likely an exaggeration, a piece of propaganda to boost morale, but looking at the intricate machine before him, Jack was inclined to believe it. Over the next few weeks he would learn its secrets. The Norden wasn't just a sight, it was an analog computer. It was a mechanical brain. Inside its casing was a breathtakingly complex system of gyroscopes that kept the sight stable, automatically compensating for the roll and pitch of the aircraft. When the bombardier looked through the eyepiece, he wasn't just looking at the ground. He was looking through a powerful telescope linked to this gyroscopic platform. His job was to identify the target and then use 2 large knobs to keep the crosshairs centered on it. One knob controlled the direction, the other controlled the rate at which the crosshairs moved across the ground. By turning these knobs, he was feeding information into the Norden's brain. He was telling it, "This is the target, and this is how fast we are moving relative to it." Simultaneously, other data was being fed into the machine. The plane's airspeed and altitude were dialed in. But the real genius was how it solved the problem of wind. Wind was the bane of every bombardier. A crosswind could push a bomb hundreds of yards off target. The Norden solved this with an ingenious method. During the final approach to the target, a period known as the bomb run, the Norden was in control.
It was linked directly to the aircraft's autopilot.
The bombardier would make his initial adjustments, and then the Norden's gyros would detect any deviation caused by the wind. It would see the plane drifting sideways off the course line and automatically send corrective signals to the autopilot, which would adjust the plane's rudder to crab it into the wind, keeping it on a perfect straight path to the target. The bombardier was no longer just an aimer. He was the navigator and pilot for the most critical 30 seconds of the mission. The Norden was flying the plane. All Jack had to do was keep the vertical crosshair centered on the target as the mechanical brain worked its magic. It calculated the precise moment, the exact split second in space-time when the bomb must be released to account for gravity, forward momentum, and air resistance to hit the point he was looking at. When all the calculations were complete, the sight would trigger the bomb release automatically. The bombs would fall not because a human pushed a button, but because a clockwork oracle had decreed it was time. The man behind this marvel was Carl Norden, a Dutch engineer who had emigrated to the United States. He was a notorious perfectionist, an obsessive genius who worked tirelessly to refine his creation. He saw bombing not as an act of destruction, but as a technical problem to be solved with mathematical precision. He believed his invention would make war more humane by making it more accurate, allowing armies to destroy military targets without harming civilians. It was a noble, if naive, vision. The reality was that his creation, the Norden Mark 15, was a masterpiece of 20th century mechanical engineering. It contained over 2,000 individual parts, gears finer than a watchmaker's, and gyros that spun at thousands of revolutions per minute. It was a temperamental beast, sensitive to temperature changes and vibrations, and it required a highly trained specialist to operate and maintain. But in the controlled environment of a training facility, it worked miracles. Jack would spend hours on the training rigs, bombing moving targets projected onto the floor. Again and again, the machine would release its dummy bomb at the perfect moment, scoring a direct hit. The confidence it inspired was immense. It felt less like a weapon and more like a surgical instrument. He and his fellow bombardiers were being trained not just as soldiers, but as technicians, as the high priests of a new cult of precision warfare. They were the men who would wield the pickle barrel sight, and they believed with every fiber of their being that it would make them invincible. Back in Germany, the wheels of intelligence were grinding. In the Berlin headquarters of the Abwehr, Germany's military intelligence service, Oberst Schmidt was compiling a troubling file. The file was thin, filled mostly with rumors and snippets from interrogations of downed airmen. But a name kept appearing: Norden. The first reports were dismissed as bravado. American prisoners, when questioned about their bombing accuracy, would speak of a new secret bomb sight. They called it a computer. They claimed it made missing impossible. German intelligence was skeptical. They knew the challenges of high-altitude bombing better than anyone. They believed their own Zeiss optics were the pinnacle of technology. But as 1942 turned into 1943, the evidence began to mount. The American 8th Air Force was beginning its daylight bombing campaign against occupied Europe. Their formations of B-17 Flying Fortresses and B-24 Liberators were high-altitude affairs, attacking from 25,000 feet, far higher than the Luftwaffe's medium bombers typically operated. And their bombing, while far from perfect, was showing a level of concentration that was alarming. Reconnaissance photos of American raids on submarine pens in France or airfields in Holland showed bomb patterns that were tighter, more focused, and more destructive than the scattered results the Luftwaffe was used to seeing. The file on Oberst Schmidt's desk grew thicker. The name Norden became an obsession for the Luftwaffe High Command. Hermann Göring, the flamboyant and increasingly desperate head of the Luftwaffe, demanded answers. His own bomber force was being decimated on the Eastern Front and was proving ineffective in its renewed attacks on Britain. He saw the American Daylight campaign as a direct challenge to his Air Force's honor and Germany's security. If the Americans possessed a device that could guarantee accuracy from high altitude, it represented a strategic threat of the highest order. He ordered the Abwehr to acquire the Norden secret at any cost. What Göring and Schmidt didn't know was that, in a sense, they already had it. The most critical part of the espionage had already taken place, not in the skies over Europe, but in a factory in New York City, before the war had even begun for the United States. A German-born man named Hermann Lang was a naturalized American citizen who worked as a draftsman and assembly inspector for the company that manufactured the Norden Bomb Sight. Lang was a loyal Nazi, a member of a German spy ring. Over several years, he had used his position to meticulously study the bomb sight's design. He had a photographic memory, and piece by piece, he memorized the intricate blueprints of the device. During a visit to Germany in 1938, he met with German military officials and reconstructed the plans from memory. It was one of the most significant acts of espionage in history, and the Americans were completely unaware of it. The Abwehr had the blueprints. German engineers, working with the brilliant minds at the Carl Zeiss Optics Company, set about creating their own version. They called it the Carl Zeiss Luftwaffe 7V. On paper, it was a near-perfect copy of the Norden. It had the same complex gyroscopic stabilization system, the same autopilot link, the same calculating mechanisms. But when they built the prototypes and tested them, a frustrating problem emerged. It didn't work as well as the original was reported to. It was prone to glitches, the gyros weren't as stable, and the calculations were often slightly off. The German engineers were baffled. They had the plans, they had some of the finest manufacturing capabilities in the world. So what was wrong? The answer lay in the subtle, almost imperceptible differences in manufacturing philosophy. Carl Norden had been a fanatic about quality control. The tolerances for the parts in his bomb sight were measured in millionths of an inch. The ball bearings used in the gyros were polished to a near-perfect sphericity. The lubricants were specially formulated. The American system of mass production, honed by the automotive industry, was capable of producing these incredibly precise, interchangeable parts on a massive scale. German engineering, while excellent, was more akin to craftsmanship. They could build a superb prototype, but replicating the thousands of hyper-precise components needed for a device like the Norden under the pressures of a wartime economy was another matter entirely. Lang's memory, while prodigious, had also missed some of the subtle but critical details about the materials used and the precise assembly techniques. The German copy was a superb piece of engineering, but it lacked the almost mystical perfection of the original. It was a Stradivarius copied by a master craftsman. It looked the same, but it didn't produce the same music. So the obsession continued. Having the plans wasn't enough. They needed a real intact Norden. Luftwaffe fighter pilots were given new orders. When engaging American heavy bombers, try to force them to land rather than shooting them down. A captured B-17 could yield the ultimate prize. Every downed fortress or liberator was scoured by intelligence teams, hoping to find the remains of a bomb site that hadn't been properly destroyed by its bombardier. But the American crews were diligent. They had taken their oath seriously. The teams would find only melted, charred lumps of metal, the Norden's secrets consumed by thermite. For men like Hauptmann Klaus Richter, this was all academic. He wasn't an engineer or a spy. He was a pilot, and what he saw with his own eyes was what mattered. By late 1943, he was no longer flying bombing missions over England. He had been transferred to a new role, flying a Messerschmitt Bf-110 destroyer, a heavy fighter tasked with attacking the American bomber streams. Now he was seeing the Nordens work from a different perspective. He would fly parallel to the great combat boxes of B-17s, watching as, in perfect unison, their bomb bay doors would swing open. And then the bombs would fall, not as a scattered random rain of death, but as a cohesive, shimmering curtain of steel, plummeting towards the earth. He saw the Focke-Wulf factory in Marienburg disappear under a carpet of explosions so concentrated that the entire complex seemed to lift into the air before disintegrating. He saw the ball-bearing plants at Schweinfurt, the lifeblood of the German war machine, plastered with bombs time and time again. The bombing was not, as the American propaganda claimed, as accurate as a pickle barrel, but it was good enough. It was terrifyingly, relentlessly good enough. It was better than anything the Luftwaffe had ever achieved. The whispers in the mess halls grew louder. The American bombardiers were like surgeons, dissecting Germany's industry from 5 miles up, and the tool they used, the source of their power, was the Norden. The cold bit at Jack Riley's fingers, even through his thick gloves. The perspex nose of his B-17G, which he had nicknamed Nose Art, offered a panoramic and terrifying view of the world. At 27,000 feet, the sky was a deep, dark blue, but the world below was a canvas of deadly beauty. Around him, the air was filled with hundreds of other fortresses, their silver wings glinting in the sun. And between them, the sky was pockmarked with the ugly black smudges of flak. Today's target was the synthetic oil refinery at Merseburg. It was one of the most heavily defended targets in Germany. The bomb run had just begun. "Autopilot engaged. Plane is yours, Jack," the pilot's voice crackled over the intercom. A small light glowed on the Norden's control panel. Jack was now flying the 10-ton bomber. He hunched over the eyepiece, his world shrinking to the circle of magnified German landscape below. The flak was getting thicker. The plane jolted violently as a shell exploded nearby, a sharp crump that he could feel in his teeth. He ignored it. His entire being was focused on the 2 knobs in his hands. He could see the target now, a confusing sprawl of pipes, towers, and storage tanks. His briefing photos were strapped to his knee. He identified his specific aiming point, a critical distillation tower. With delicate movements of his right hand, he adjusted the azimuth knob, slewing the vertical crosshair onto the tower. With his left hand, he adjusted the rate knob, synchronizing the horizontal crosshair's movement with the ground speed. He could hear the chatter of the waist gunners, their .50 caliber machine guns barking at enemy fighters. A shadow flashed past his window. A Focke-Wulf 190, its cannons blazing. He didn't flinch. His job was here, in this bubble of concentration. The plane was crabbing, the Norden's brain automatically correcting for a fierce crosswind. The crosshairs kept drifting slightly off the tower. Sweat beaded on his forehead, threatening to drip into his eye. He fought the urge to rush. The 30-second bomb run felt like an eternity. The machine was doing its work, the gears spinning, the gyros humming, calculating the moment of release. He just had to give it the right information. He had to be perfect. Suddenly, the crosshairs began to drift wildly. "We're hit! We're hit! Number 3 engine is on fire!" the co-pilot yelled. The plane lurched, dropping a wing. For a split second, Jack's view was filled with nothing but empty blue sky. Panic clawed at his throat. The bomb run was ruined. All this way, all this risk, for nothing. But then, he felt the plane stabilize. The pilot was fighting the controls, wrestling the crippled bomber back onto a level course. "Hold her steady, goddammit! Just hold her steady for 10 more seconds!" Jack screamed into his throat mic, not sure if he was even transmitting. He found the target again. It was off to the side. He furiously spun the azimuth knob. The final seconds were ticking away on the timer dial. The crosshair was almost there. Almost. And then it settled back onto the distillation tower. A jolt ran through the aircraft. But it wasn't from flak. It was the bombs. The Norden had automatically released the payload. "Bombs away!" he yelled. A wave of immense relief washing over him. "Let's go home." The plane banked steeply, turning away from the target and the flak-filled sky. Jack didn't look back to see if they had hit their mark. That was for the reconnaissance photos to decide. His job was done. His part of the brutal equation was complete. He had brought the Norden to the heart of the Reich and given it a chance to work its magic. The reality of missions like this one chipped away at the pickle barrel myth. Combat was not a laboratory. Planes were damaged, bombardiers were wounded, clouds obscured targets, and the sheer terror of being hunted by fighters and bracketed by flak could disrupt the concentration of even the most seasoned veteran. Analysis after the war would show that only about 50% of American bombs dropped using the Norden landed within a quarter-mile of their aiming point. The pickle barrel remained a fantasy, but that 50% was a revolutionary achievement. It was a level of accuracy that was previously unimaginable in high-altitude bombing. It was enough to systematically dismantle the German war economy. It was enough to make the German pilots look up at the bomber streams with a mixture of hatred and profound professional respect. Hauptmann Klaus Richter stood before his commanding officer, a weary but determined general major from the old school of Prussian aviators. Richter had been requested to give a frontline pilot's perspective on the American bombing campaign. "General Major," Klaus began, his voice steady, "their fighters are a problem. Their defensive formations are formidable. But their true weapon is not the fortress or the liberator. It is their bomb sight." He paused, choosing his words carefully. "We have seen the reconnaissance photos. We have interrogated the captured crews. I have seen their bomb patterns with my own eyes. They are able to place their bombs on a target with a consistency that we simply cannot match. The raid on the Marienburg factory, it was not a raid, it was an annihilation. They effectively removed it from the map in one afternoon." The general major steepled his fingers, his face grim. "Our engineers at Zeiss tell me their new models are improving. They tell me our bombardiers are the best trained in the world. Our bombardiers are superb." Klaus agreed immediately. "Franz, my old bombardier, could fly a plane better than some pilots, but he was fighting his instruments. The Luftwaffe 7 is an excellent optical device, but it requires the bombardier to be a human computer. He must judge the drift, calculate the release point, all while under extreme duress. The American system, this Norden, it does the computing for him. The bombardier simply points, and the machine flies the aircraft and drops the bombs. It removes the largest source of error, the human factor under fire." He leaned forward, his voice dropping with intensity. "We have captured fragments. Our intelligence officers have studied the schematics our spies acquired before the war. Everyone agrees it is a masterpiece of mechanical engineering. The gyroscopes, the autopilot connection. It is years ahead of our own technology in this specific field. We are fighting a surgeon's scalpel with a butcher's cleaver." This was the moment. This was the begging. It wasn't a plea for mercy. It was a desperate cry of technical envy. It was the professional admission of a warrior who recognizes a superior weapon in the hands of his enemy. It was a sentiment being echoed in official reports and informal discussions throughout the Luftwaffe. Pilots who had risked their lives to attack the bomber formations would return to base, shaking their heads in frustrated admiration. They had seen what the Norden could do, and they wanted it. They begged their engineers for a copy. They begged their leaders for a solution. They begged for a tool that would allow them to be as effective, as precise as the Americans. The High Command understood. They poured resources into perfecting their own bomb sights. The Luftwaffe 7 was continuously upgraded. They even developed a more advanced system, the BZG-2, for their jet-powered Arado R-234 bomber. It was a good system, but it came too late, and there were too few of them. The fundamental gap remained. The Norden, produced by the thousands and operated by an army of trained bombardiers, had given the Allies a decisive technological edge in the strategic air war. It was an edge built not just on a clever design, but on a foundation of mass-produced precision that the German war machine, for all its prowess, could not replicate. The legend of the Norden had permeated the Luftwaffe, becoming a symbol of the enemy's seemingly infinite industrial and technical resources. In the end, the Norden Bomb Sight was a transitional technology, a brilliant mechanical solution to a problem that would soon be solved by electronics. In the post-war era, radar bombing and then primitive digital computers would render its intricate clockwork obsolete. Its service life was relatively short, but its impact was immeasurable. It was never the perfect weapon of the propaganda posters. The pickle barrel was safe. But the Norden represented a monumental leap in the deadly science of warfare. It gave the Allied air crews a crucial psychological advantage, a deep-seated confidence, however misplaced at times, that they could strike their targets with precision. This confidence was vital in sustaining their morale through some of the most brutal and costly campaigns of the Second World War. And for the men on the other side, for pilots like the fictional Klaus Richter and his real-life counterparts, the Norden was a constant, frustrating reminder of the technological chasm that had opened between them and their adversaries. They did not fear the American pilots or gunners any more than they feared the British or the Russians. They were confident in their own skills and their own courage, but they envied their enemies' tools. They saw in the Norden Bomb Sight a reflection of a system that could produce not only thousands of airplanes, but also the thousands of impossibly complex, miraculous little black boxes to go with them. The German pilots who begged for the American bomb sight were not asking for a shortcut or an easy way out. They were asking for a chance to fight on equal terms, to bring the same level of scientific certainty to a conflict that was increasingly being decided not just by bravery in the cockpit, but by the genius of the engineers in the laboratory. The story of the Norden is the story of a secret that was too good to keep, a legend that crossed enemy lines, and a testament to the fact that sometimes, in the crucible of war, the highest form of flattery is a desperate, envious desire for your enemy's weapon.